Welcome back, guys. So today we're going to talk about exponential functions. In your previous module, you explored systems of equations where you dealt with linear equations. And today we're going to go into another topic, exponential functions, which deal with curves that are not linear. So before I go into the actual lesson, let's review exponents. Right, so when we did exponents before, remember that exponents take a base and then we raise it to some power. And what we do is repeated multiplication. So the exponent tells you how many times your base should be a factor. So for example, we have this chart that has the powers of base 5. And we want to figure out what 5 raised to the 0 power is, and what 5 to the negative 1 and 5 to the negative 2 power is. Okay, so as you can see, between our output values, we're dividing by 5 each time to get to the previous value. So what we want to do is we want to continue using this pattern. All right, so let's fill in this chart. Okay, so in order to get 5 to the 0, we want to take our 5 here and we want to divide it by 5 because that's our pattern. Okay, so let's divide it by 5. And if we do that, 5 divided by 5, so our previous value divided by 5 is 1. Okay, and then we want to continue this pattern. So if I take our previous value 1 and divide it by 5, then we get 1 over 5 here. And then the same thing, 1/5 divided by 5. So we're taking a fraction and we're dividing it by 5. So remember your KCC. We change to multiplication and change our second to a fraction, and so we get 1 over 25. And so that's our value that goes here. Okay, so when we're dealing with negative exponents, we don't always want to make a table of our values and then find what factor we're dividing by. So recall that whenever we have a base raised to a negative power, what we do is we take the reciprocal and make the power positive. Okay, so now let's look at what an exponential function actually is. All right, so an exponential function is a function in which the input values increase, and once we put in our input values, we get these output values that are related by a constant ratio. All right, and here I highlight successive output values. Successive means that they're in a specific order, not to be confused with consecutive. Consecutive means, so I have 1, 2, 3. These are consecutive integers. Or consecutive even integers is 2, 4, 6. Successive means that it's just in a specific order. So my first value could be 3 and the next value could be 8. It doesn't necessarily have to be 3 and then 4. Okay? And so our standard form of an equation for these exponential functions that we're going to be dealing with is f of x equals a times b to raise to the x power. Okay? Where x is going to be our input. So this is our input. And then f of x is going to be our output. All right, and this a and this b, they're not, when we see these, we usually think of variables. They're not variables. These are constants that we will determine these constants in our next lesson when we go into a little bit more detail about how to find the actual equation for an exponential function. All right, so let's look at just a normal exponential function, and we want to find some ordered pairs for it and see what the graph of this exponential function looks like. All right, so we have this function f of x equals 5 raised to the x, and we want to find the output values for our input values of -2, -1, 0, and 1. All right, so let's plug those into our table. So when we do that, we get 5 to the -2, which remember is 1, we get the reciprocal. And so this is our ordered pair should be -2, 1 over 25. Okay, and the same thing for the second one. 1 over 5 to the 1, but 5 to the 1 is 5. So we get -1, 1/5. And then anything raised to the 0 power, any base raised to the 0 power, is clearly 1, so we get 0, 1. And then 5 raised to the first power is 5, so we get 1, 5 is our ordered pair. All right, and so let me just grab a different color here, and then we're going to plot this. So the first thing we want to do actually is we want to fill in our axes. So let's go here. We have 1, 2, 3, 4, -1, -2, -3, and let's go 1, 2, 3, 4, 5. So this is a 4. Let's make that clear. 6 and 7. All right. So -2 is 1 over 25, which is very close to 0. All right. So that's going to be right here. Okay. And -1 is 1/5, so that's going to be slightly above that next point. So let's go here. All right, and 0, 1 is here. And 1, 5 is going to be way up here. So you see that between 0, 1 and 1, 5, we have this big jump. That's what exponential functions, that's what happens when you look at an exponential function. It doesn't increase at a linear constant rate. The rate that's between each pair of outputs jumps really high. Like here it starts off small, but then you see this big jump here. And then when we actually plot the curve, all right, so we're going to go straight across, and then it's going to jump up here, as so, and it should go through that point. So, okay, and so you see we get this curve, and it's not a linear function. Okay, so now let's look at another example where it's not so, our b is not an integer, right? Our b is a fraction. So here we have the function 2 times 2 over 3 raised to the x power. Okay, and we want to, again, like in the previous example, we want to fill in this chart for our values, our input values. So now we have -2, -1, 0, 1, 2, and 3. Okay, and so all we're going to do is we're going to replace our x here with our input values. So we have 2 times 2 over 3 raised to the -2nd power. And before I go into the next step, let me point out that I don't want you to get confused when you see these parentheses. That doesn't mean 2 times 2 over 3 and then raise it to the 2nd power. Remember, let's recall our PEMDAS where we have to do exponents first and then do multiplication. So you want to raise this 2/3 to the -2nd power first and then multiply by 2. Okay? So when we do that, we're going to bring back our 2 in the front, and then remember we have to get rid of this negative exponent. So in order to do that, we take the reciprocal, which is 1 over 2/3, and raise that to the +2nd power. Okay? And so we have 3 over 2 raised to the +2nd power. And so we get 2 times 9 over 4, which is 9 over 2. Okay, so our ordered pair is going to be -2, 9 over 2. All right, and then we're going to fill in for the second value, -1. And so we get 2 and -1. So we get, remember this becomes 3 over 2 after we flip and do our reciprocal, raised to the first power. So that's just simply 2 times 3 over 2, which is 3. So our second point is -1, 3. Okay, and then we fill in for 0. So this is 2 over 3 to the 0 power. And remember, anything raised to the 0 power is 1. So this part right here becomes 1. And so we just simply have 2. So our ordered pair is 0, 2. And then 2 times 2 over 3 to the first power. So that's just simply 2 times 2 over 3, which is 4 over 3. And so we get our ordered pair is 1, 4 over 3. Okay, and then 2 times 2 over 3 squared So we get 2 times 4 over 9, which is going to give us 8 over 9. And so we get 2 8 over 9. And then we have 2 times 2/3 to the third power, which gives us 2 times 8 over 27. And so we get 16 over 27. Okay, so our ordered pair is 3, 16 over 27. Okay, and so if we slide down, we want to graph this. And so when you graph it and we graph these points, our graph looks like this. And so we get that as our x values increase, our graphs, our outputs decrease at this rate. Okay, and so that is the end of today's lesson.